All right, everyone. This is homework 8 or homework chapter 8, homework number 6. All right, so chapter 8, homework number 6. So today we started with a little bit of graphing. Just you guys are supposed to finish the backside or just on your own time, but plenty of practice on this one as well. All right, number 19 is done for you already. You look at that. To the x power, they graphed it. They did the the y-intercept. They did the asymptote, which is y equals 0, and they did the growth for decay. This is a growth function. Growth is just a increasing function. Decay is a decreasing function. All right, that's all you have to do, at least on this assignment. So 4 to the x power. All right, so I'm actually going to use this little. You can do it on the calculator, you can do it on Desmos, but it's not going to be as good. All right, so 4 to the x power, if you do your x and y table, let's do a couple of them, right? So let's do negative 2, negative 1, 0, 1, and 2. Let's do these values. All right, so use a calculator. So this is a function right here, 4 to the x. So you can use 4 to the power of. And when you use power of negative 2, so we will get 0.625, right? So basically the idea is that you get 0.06. Okay. That 25 is pretty small. So this is, if we're comparing it to a dollar, this is 6 cents, right? So you can do it again, pull it up. Instead of negative 2, put negative 1, and 0.25. So this is 0.25. If you compare this to a dollar, this would be like 25 cents. Okay, pull it up again. 0 in there. Okay, so 4 to the second to the 0 power makes 1. One more time. 4 to the 1 power. Most of you guys already know these, but I'm showing you how you would do it on the calculator. 4 to the 1 power, or 4 to the first power is 4. And most of you guys know what 4 to the second power is, but in case you don't, it's 16. All right, so we're going to go ahead and graph each of these. All right, so negative 2, which is right here. Okay, and if you are careful, each of these goes by negative 2 because this one is already negative 4. So you got to be careful with that. So negative 2 would be 0.06. So it's going to be a very small number. And again, if you count on the y's, they go by 2. So 0.06 is going to be very, very small. It's going to be so small. In fact, I think it's going to be right on the x-axis, almost on the x-axis. Negative 1 would be halfway. And it's going to be about the same, but just a little bit higher. At 0, it'd be 1. It's about right here. At 1, right here, we're right here now. So at 1, it'll be 4. Okay, so at 1, I will be graphing 4. So 1 is going to be halfway. Remember, each of these is counted by 2. So 2, 4, 6, and 8. So at 1, it'll be 4. And then finally at 2, whoa, it's in pieces. It'll be 16. So at 2, which is the first block, it'll be all the way up to 16. So this is how your graph should look like. And if you're graphing it correctly, you get something like this. Okay, and if you want to use Desmos to check it out, or a graphing calculator, if you have one like me, okay, and this is the same as Desmos, and we would be graphing 4 to the x power. So for me, I type in 4 to caret or to the power of x. If I was to look at that, it would look pretty similar to what I just graphed. Okay, that's what you have. All right, so we know that we did good. Y-intercept is going to be where it crosses the x-axis or the y-axis. Y-intercept is going to be right here. Okay, so it's going to be 0, 1. Asymptote is going to be the line y equals 0. Okay, the asymptote is actually this line right here. This is the line that the graph follows. And this is a growth function. All right, moving along. actually here. Okay, number 21. So basically, if you're gonna do these by hand, just do it like how you normally would. Forget about the 4. Just get the answer and then times it by 4. That's all it is. Right? So if I was doing this, I would have x and a y. Okay, and I would do the whole thing: -2, -1, 0, 1, and 2. Right? So -2. Right? So you get 1/3. 1 divided by 3 to the power of -2. So you get 9, but you times it by 4. 36. That's a big number, and that's not even on our graph. Right, so do the same thing again. So -1 power, it's 21. You get 3, but you got to times it by 4. You get 12. Okay, if you do this 0 power, you get 1 times by 4. You get 4. You put 1 there, so pull it up again. 1/3 to the 1 power, you get 1/3, which is 0.333 times it by 4. You get 1.33. So I'll do 1.33. Okay, let's do it twice and pull it up again. Do it to the second power. You get 0.111 times it by 4. You get 0.444. So this is actually 0.44. Interesting, huh? Okay, so let's graph that. So -2 is 36. So at -2, it's way over there. So it's not even there. And -1 is 12, which is about right here. That's -1 and 12. At 0, it'll be 4. At 1, it'll be 1.333. So at 1, it'll be a little bit over 1. At 2, it'll be 0.444. So which is a little bit about halfway. So if I was graphing this, it would probably look something like this. Oops. And I can double check on my graph. This is going to be 4 times 1/3 to the x power, just like that. If I was to graph it, it would cross it at the 4 right here. Okay, so it looks good. Y-intercept is going to be right here at 4. So 0, 4. Asymptote is still going to be y equals 0, and this is a decay because it's coming down. Okay. Okay, 8 to the 1/4. Okay, so same kind of idea. Okay. But because I know a couple of things already, I can already answer some questions. But we can go ahead and do the whole thing. Again, we're gonna do the same thing again. And make an x and y table. -2, -1, 0, 1, 2, and this time we're using 1/4. Then when we get the answer, we're gonna times it by 8. Okay, so 1/4 to the power of -2. That's 16 times it by 8. That's a big old number. 128. So the answer is 128. Okay, do the same thing, but this time times it by -1. Get 4, and I don't need to do the math here. 4 times 8 is going to be 32. Okay, if I do it again with 0, you get 1. So if I do it again, I get 1 times by 8, I get 8. I put 1 in, I get 1/4. So 1/4 to the 1 power is 1/4, which is 0.25. Times it by 8 is going to give me a nicer number 2. Okay, and then let's do the same thing. You want to pull up the previous one, just keep doing second entry. All right, so we're going to put in 2. We're going to get 0.0625, and we times it by 8, it'll be 1/2, so it'll be 0.5. Okay, so our graph, -2, going to be way up there. -1 is going to be 32, which is way up there still. And 0 is the first time you see something. So 0 is going to give you 8. 1 is going to give you 2. Okay, so 1 is halfway, and 2 is just the first line. And at 2, you're going to get 0.5. So that's going to be half of 1, which is about right there. So this one's pretty crazy. This one's probably going to be way up there. It's going to look kind of like that. Okay, I'm going to take a look at it. This is 8 times 1/4 to the x power. We graph it to be very sharp. Okay. Actually, it's more like this, yeah. And as I'm looking at their graph, at the graph of the graphing calculator, it's more like from here. Okay. Okay, y-intercept is going to be right here. Cross the y at 0.8. Asymptote is still going to be y equals 0. Asymptote is always going to be this line here. And this is a decay function as well. Okay, so we're going to go ahead and use the 5 to the x power. We can do most of this. So x and y. -2, -1, 0, 1, 2. So 5 to the -2, 0.4, and we got to times it by 2. So times it by 2 gets 0.8. Or 0.08, excuse me. Okay, we put -1 in there. So you see how I pull up the previous answer? Well, I want the previous one, so I have to do it again. Second, enter again. So I get the previous one. And I'm going to change it from -2 to -1. And I get 0.2. And then I'm going to go ahead and multiply by 2. And I get 0.4. So 0.4. Okay, I'm going to go ahead and do 0. Again, I want the previous answer, so I'm going to put a 0 in. I get 1. 1 times 2 is 2. And this one's easy. If I put 1 in there, I get 5. Right, 1, it goes in here, you get 5. 5 times 2 is 10. If I put 2 in here, I put 2 here, I get 25. 25 times 2 is 100. Or, sorry, 25 times 2 is 50. All right, so this one goes at -2, it'd be 0.08. So basically on the line. -1 is going to be a little bit about halfway, a little bit under halfway. At 0, it'll be 2. At 1, it'll be 10. That's about all I got. Right, so you got something like this. That's your function right there. Okay, and again, if you graph it, 2 times 5 to the x power. If you graph it, it looks like that. This is definitely a growth because it's growing. It starts off small, but it gets big. Y-intercept is always going to be y equals x, or y equals 0. Okay, last one for this page. 2 to the x power. So we'll use purple for that. So we got x and a y. 2 to x power. So you're going to use -2, -1, 0, 1, and 2. All right, so 2 to the -2 power, we get 0.25, and we're going to times it by 5. So we get 1.25. Okay, same thing again. 2 to the -1, get 0.5, and you're going to times it by 5. Because right here it says times it by 5. So whatever you get, times it by 5. And you get 2.5. So, okay. You put 0 in there, you get 1, and 1 times 5 is 5. You put 1 in there, you get 2. 2 times 5 is 10. You put 2 in there, you get 4. And I'm not doing this calculator because I know these right here. So you put 2 in there, so 2 into the x. So 2 squared is going to be 4. 4 times 5 is 20. All right, so my graph's going to go -2 and maybe barely above 1. About right there. And -1 is going to be 2.5. At 0, it's going to be 5. And at 1, it's going to be 10. So we're already maxed out. So our graph is going to look something like this. Okay, this is a growth because it is growing from left to right. It's going up. The asymptote y equals 0. Oh, then y-intercept. I forgot this one. Y-intercept is going to be right there, which is going to be 0, 5. Okay, y-intercept for the last round is right here, which is at, I got these mixed up. Asymptote. Y-intercept for the last problem, number 23, is going to be 0, 2. Okay, that's the first page. Okay, back page. We're ready to deposit $5,500 in the bank account. The money earns interest annually. Table shows the balance of the account over the past several years. All right, so we're just kind of looking at some of those numbers. Is the account a simple interest account or a compound interest account? How can you tell? Simple interest is if you start with 5,500, and if you're going from 1 year to the next year and it's adding the same thing, then it's simple interest. All right, so let's see how much we're adding. So the first year to the 0 year. So first year is going to be 5650, and we subtract, and we'll find out how much we made. So that means that from the 0 year to first year, we're adding 150. Okay. Now let's look at from the let's look at it from the second year to the first year. So second year is 5,800, and we're going to minus the first year, which is 5,650. And you know what? We're adding the same thing. See that? So it's plus 150. You take the next year and subtract the previous year. So let's do the last one, right? 610 or 6,100 minus 5,950, and look, it's 150. So we know from year 3 to year 4, we're adding 150. Okay, we didn't do the year 2 to year 3, but I can bet you know what? It's going to be plus 150 as well. So this one's going to be simple interest. Okay, because the interest amount is always $150. Okay, that's how we know, because the interest amount is always the same, which is $150. Find an equation that models that, right? And how much Maria will have at the end of T years. So because we're adding 150 and we don't know the percent, it's okay because we already know the 150. So you can write it like this. You can write it as I'll call it M for Maria after so many years. We start with 550 and we're adding 150 every year, so it's plus 150 for T years. Okay, and we can do that for number 4. All right, so we put in 550. Oops. 5,500 plus 150, and then if we want it for 4 years, we just times it by 4, and look, we get 6,100, which actually matches right here. Okay, so that actually works. Okay, so that's our equation for Maria. Okay, Hector, same kind of idea, and I can probably tell you this is going to be a compound. So it's 5,500. Hector puts it in the bank account, earns interest annually, blah blah blah, shown below, right? So is this account simple or compound? So again, the test if it's simple, you're going to take the year one, which is 5720, and you subtract year zero, 5,500. And that means that for the first, to get put in there for the first year, you get positive 220. Okay. But I can bet you that the second to the first year is not going to be 220. So 5948.20 point 80 cents minus 5720, and see, the next year you're actually adding a different amount. The next year, from the first year to the second year, you're actually making $228.80. See how it's a little bit more, and it's gonna keep getting bigger and bigger from there. All right, so this one is gonna be compound interest, because the amount of interest is adding, or is more. How about this? More and more each year. Okay. Number 28 says, hey, guess what? The account grows at 4% interest. Find an equation that models the amount. So this one will be easy because they gave us the interest rate. So this would be, and since this is we're talking about Hector, we'll call this H of T for Hector for so many years. And because we start with 5,500, that's going to be 1 plus the 4%. And because it's growing, we're adding it. So 0.04 to the T power. Okay. If you want, you could write it as 5,500, and you could add the 1 and the 0.04 to make 1.04 to the T power, right? We can double check it, see if that works for 4 years. So 4 years, it should come out to be 6,434.22 cents. So we use 5,500 parentheses 1.04 to the power of 4, right? So you get 6,434.22 cents. So that actually works out. Check. All right, that's all for the show, guys.